Hey TechKnowStuds! After working with computers for a while, you'll start noticing that there's some numbers that come up very consistently. Like 256 for some reason comes up a lot. But why does it come up a lot? Well, it really boils down to those binary numbers and the powers of 2. So in this lesson, let's take a look at binary numbers and those powers of 2. If we have 1 bit, it could be either a 0 or 1. So it can be in 2 different states. So when we have 1 bit, there are 2 states with this. So how many combinations can we think of when we have 2 bits? Well, we could have 0, 0, we could have 0, 1, we could have 1, 0, and a 1, 1. So now we have 4 possibilities. 1, 2, 3, 4. And so we've doubled the amount of possibilities that we have. And if you think about it, it really makes sense because we still have that single bit, could be a 0 or 1. And now we have an extra bit, which could be a 0 or a 1. So we've doubled the amount of combinations we have by adding an extra bit. Let's do that again. Here we have 3 bits. So we've got 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. We've got 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So 1, 2, 3, 4, 5, 6, 7, 8. We have 8 combinations here, 8 different ways that we can represent this with 3 different bits. And this makes sense as well, because in this case right here, we have the 4 combinations we had with 2 bits, but we could do that with a 0 as the 3rd bit or a 1 as a 3rd bit. So we've doubled the amount. So now every time we do this, we double the amount. If we have 4 bits, how many combinations do we have? So what I'm going to do is I'm going to let you figure this out. Go ahead and figure out what this answer is with 4 bits. And you can do it 2 ways. You can do it the pattern that we've already discovered where we double it every time. And actually you could also figure out what are all the combinations of 1s and 0s that you can possibly have. So go ahead and try to figure that out. Pause the video, and then when we come back, we'll discuss the answer. So if you came up with the answer of 16, then you'd be correct. It's twice as much as 8. So we know from the pattern is that we're going to have 16 different combinations. But what are those combinations? Here's a list of those combinations. And if you noticed, it's the same combinations here for the first 3 bits. But since we can do it all as 0s and then again all as 1s, we have another set of those same combinations again. So this is all of the answer here. And if you want to pause the video and check your work, this is an opportunity to do that. So here are a couple other ways to look at this. If you just have a single bit, there's 2 possibilities. If you have 2 bits, it's 2 times 2. If you have 3 bits, it's 2 times 2 times 2. And if you have 4 bits, it's 2 times 2 times 2 times 2. We can just shorten that to 2 to the 1st power, 2 to the 2nd power, 2 to the 3rd power, 2 to the 4th power. So it's 2 to however many bits that you have is going to be what the answer is. And so now we get, in both these cases, 2, 4, 8, 16, and so on and so forth. Here's the rest of that. We're going to go out to the 2 to the power of 8th. So if you want to figure these out, go ahead and pause the video and then we'll come together and look at the answer. And here are the answers: 32, 64, 128, 256. So these are common numbers that you'll see on computers. If we take this all the way out to 2 to the 16th power, we get 65,536. Now these numbers are going to show up a lot on computers. In addition to, it can keep going. So you'll still see these numbers, the powers of 2, which is a lot of times why we see these strange numbers pop up on our computers, is because what it's doing is it's calculating a lot of the information that it has with these powers of 2. So you need to be familiar with these, especially the first 8. These are going to be something that you're going to encounter a lot, especially if you're getting into subnetting or if you're getting into working with like certain type of processing. Certain programs will have limits that you'll see here. And so you'll see it a lot, and it can be applied in a lot of scenarios when it comes to working with computers.